Hello, welcome to this lesson. In this lesson, we will discuss the basic introduction to integration. Integration is also called continuous summation, and it can be used to find areas, volumes, central points, and many useful things. Okay, and we say that integration is the opposite of differentiation. Okay, so now when you have, let's consider areas under a curve. Integration can be used to find area under a curve. Okay, so let's consider a Cartesian plane and our function f of x. Okay, so now if you want to find the area under this curve, then first of all you can divide this curve into slices. Okay, so let's divide this curve into slices. So we have this, we also have this. Okay, we also have this. We also have this. Then we have that. Okay, such that each of the slices have the same width. Okay, that is delta x. Okay, the same width, they have equal width. Okay, so first of all, you see under the curve we have divided into what slices. So we have first one, second one, third one, fourth, and the fifth one, and each of them are rectangular in shape. So if you want to calculate the total area under this curve, that's the area of the first rectangle plus area of the second rectangle plus the area of the third rectangle plus the area of the fourth rectangle plus the area of the fifth rectangle. Okay, now you realize that there are still spaces. Okay, there are still a lot of spaces under a curve, and it means that our answer, our result, it will be an approximate result but not an exact result. And we can improve this result by minimizing the width. Okay, by minimizing the width. And when we do that, this is how it's going to be. So we have our function f of x, okay, our function f of x, then the area, is we just divide it into slices. Okay, but this time we are going to minimize the width. Okay, so we minimize the width, so we have this. Okay, 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 okay. So you realize that, you see, so we find after minimizing the width, we find the area of each of the slices under the curve. But we realize that after, when you try to minimize the sizes or the width of the slices, the space under the curve will be reduced. Okay, thereby improving the area under the curve, improving the results. Okay, so as you minimize the size, you obtain a better result. Okay, as you minimize the size, we obtain a better result. Mathematically, then we can say that as delta x approaches 0, then our results get better and better. And as delta x approaching 0, it means that our delta x is what? Instantaneous. And therefore, our sigma sign, okay, our sigma sign is just going to change into what? An integral sign. Okay, so integration is one of the easiest method to find that is used to find what? Area under a given curve. Now, we all know that integration is what? Just the opposite of differentiation. Now let's prove this. So let's consider a polynomial function, okay, ax to the power n plus c, where a and c are any arbitrary constants. Okay, now first of all, we will find the derivative of this function. Okay, then after that we try to integrate our results to check if we will get back the function. Okay, so first of all, we find, since the function f is a function of what? F is what? A function of x. It means that x is the independent variable. Okay, so we differentiate f of x with respect to x. Okay, and when we do that, we get this. Okay, so the derivative of ax to the power n is given by na times x to the power n minus 1, and our c is constant, and therefore our derivative of a constant is what? Always 0. Conversely, let's differentiate, let's integrate our results. When you integrate this f prime of x can also be written as what? D dx of what? F of x equals to what we have on the right hand side. Now we can multiply through by dx, and when you do that, we obtain this. Okay, then we integrate both sides. And when we do that, per the rules of integration, you see n is a constant, any arbitrary n is a constant, that's the exponent, and a is also a constant. And since the integral sign is a linear operator, it means you can bring the constant out of the integral sign. Okay, so we get this. Then per the rules of integration, the integral of x to the power n minus 1 is given by that plus any arbitrary constant. But n minus 1 plus 1 is just n plus 0. So we get what? X to the power n divided by n plus any arbitrary constant. And this n can cancel n. Then a times x to the power n is ax to the power n plus any arbitrary constant. This shows that an integration is just an opposite to what? Differentiation. In our next video, we will discuss and solve more examples on methods of integration. Thank you.